In this lesson, we are going to learn about heat capacity and specific heat. To start off, heat capacity is simply the amount of heat needed to change the temperature of a substance by 1 degree Kelvin. So I'll write that right here. Heat capacity is the amount of heat energy required to change the temperature of a substance by 1 degree. And again, it's going to be in Kelvin, but technically it's going to be the same if you do Celsius. Also, the equation for it, I should move this up here, the equation for it, I'm going to draw this one, oops, is C equals Q delta T. So the C represents specific heat. Let me grab. The C right here represents the specific heat. Q is the heat energy, and it's going to be divided by T. Let me actually rewrite this so it's a little easier to see. So it's going to be Q heat energy divided by delta T, which is a change in temperature. So delta means change in. There's a little triangle right there. And all it means is basically it equals the T, the final temperature, final minus T initial. So if you started at 10 degrees Celsius and ended at 20 degrees Celsius, your final would be 20 minus 10 is just 10. So your change in is just 10. An example of a heat capacity question would be that right here. So if the substance A released 10 joules of heat and its temperature increased from 200 to 202 Kelvin, what would be the heat capacity of substance A? Or what would it be? So let's just write it out here. So we remember that our equation was C, which is heat capacity, is equal to Q, that's the amount of heat energy. In this case, that would be 10J divided by your delta T. So remember, an easy way to figure out equations is just to write out every variable. C is specific heat, or heat capacity, sorry. It's a heat capacity, and we don't know that, that's what we're trying to find. We'll put a little question mark. Our Q, in this case, the heat energy, you look for joules, and you know that 10 joules is your heat released, and then your delta T, remember that's going to be your final minus your initial temperature. So in this case, we increase from 200 to 202, so delta T is going to be 202, which is our final, minus 200, and that's equal to 2 Kelvin. So if you plug this into the equation, you get C is equal to, we have 10 joules divided by 2 Kelvin, and our answer is, our C is, 10 divided by 2 is 5, and the unit for heat capacity is joules per Kelvin. Heat capacity depends on the mass of the object, so it is considered an extensive property. So let me write that down over here. Heat capacity is extensive. So if you remember from the beginning of the year, extensive properties are properties that depend on how much matter you have. So the more mass you have, the more heat energy. Think about how if you have a large pan and you're cooking something in a large pan, it takes longer to heat up the large pan than it does if you heat up a smaller pan. But because of this makes scientists like it a bit less, since they prefer to know the heat capacity regardless of the amount of energy you have. This other measure is going to be called specific heat capacity, or just called specific heat. So specific heat is defined as the energy, I should write it right here, is the energy required to raise the temperature of 1 gram, to raise the temperature of 1 gram of a substance by 1 degree Kelvin. So this is a little more specific in that now it's saying 1 gram as opposed to just any number. So the equation for specific heat is going to be it's going to be very similar. It'll look a little weird, but it is C. That's in this case a specific heat. You can write CSP for specific heat is equal to Q, which is the heat energy, divided by M, which is mass in grams, times delta T. So it's Q divided by M times delta T. In this case, mass is now in the denominator, and because of that, it is a intensive, I'll just write it right here, intensive property. So it does not matter how much you have, the specific heat of all substances will be the same for that particular substance. To go through an example, we're going to move over right here. So it says, let me move this up a bit. So it says when 200 grams of water is to be heated from 24 degrees Celsius to 100 degrees Celsius to make a cup of tea, 63,596 joules of heat energy are released. You could also turn this into kilojoules, and if you turn that, it would just be 63.596 kilojoules, but we'll keep it in joules for now. From this information, calculate the specific heat of water. So what we're going to do is set up the equation. We know that it's going to be CSP, that's the specific heat, is equal to Q, the heat energy. In this case, that would be the 63,596 joules, divided by, we have mass, and then we have delta T, mass times delta T. So let's write out what we know, and we'll solve for what we don't know. So in this case, we know, I'll write what we know on the right side right here. So let's see, we're trying to find our specific heat. So we know Q, our heat energy, is this 63,596 joules. And we know our mass, it says right there, is 200 grams. And our delta T, in this case, we have to do the difference between the final temperature and the initial temperature. So it's heated from 24 degrees, that's our initial temperature, to 100 degrees. So that's our final. So we have 100 minus 24 is equal to, remember 100 minus 24 is 76. And that is degrees Celsius. So again, if you want, if you just make it Kelvin, you just add 273, where it would be 373 minus 297, and that would also just be 76. So it doesn't matter if you do Celsius or Kelvin, as long as you keep both units in that same. So this next part, we have to actually calculate this out. So let me move down here a bit. Actually, let me move over here. So I'll give myself a little more space. All right. So we're going to take this and we'll put C is equal to, remember Q's on the top, so 63,596 joules over, and we have 200 grams times, and that's 76 Celsius, or you can make it Kelvin. So it ends up being, what we're going to do is we're going to do 200 times 76, and then make sure that's in degrees so it doesn't look any different. Let's take our calculator out, and we have, so what we're going to do is we're going to do 63,596, and we're going to divide that, and you can just do it in one go and just put a parentheses. It's going to be divided by 200 times 76. Make sure you close the parentheses right there. So you see what's happening right there. It's 63,596 divided by 200 times 76, and make sure you put equals, and you get 4.1839, which you can round to 4.184, and then the unit is joules per gram, and that's Celsius, or if you use Kelvin, it would be joules per gram Kelvin. So that is actually the specific heat of water, which will be the same for water in all cases. You can usually just find the specific heats of different substances by looking online, but the key one to remember is this for water. So let me actually just write this. This is the specific heat of water, and if you convert to calories, it's actually also equal to 1 calorie per gram in Celsius. So this is the specific heat, don't mind my bad handwriting here, specific heat of water.